Hi, I'm Miss Bryant, and today's lesson is linear functions. Linear functions look the same as a linear equation. And if you recall, a linear equation is just a straight line that has a constant change or a constant slope. They can be written with x's and y's or with other variables such as h and c. For instance, you could write c is equal to 10 times h, with h may being the amount of hours and c being the cost. This might be a little more practical to use other variables other than x's and y's. Let's look at how to write a linear function. Okay, here's our first example. The Parkwood Painting Company charges a fixed fee of $200 plus $30 an hour for painting a house. Determine a linear function to express the cost, C, in dollars in terms of hours required, T, in hours, and then draw a graph of the function. Okay, let's see. First, they charged us $200. That was a set fee. So no matter how many hours, you had to pay that set fee. Now, for every hour, they charged $30. So $30 per hour. And that was going to equal the cost to paint the house. So now, what they're telling me, though, is for every hour that they paint your house, it's going to cost $30. It's going to be an increase of $30. So if it took 10 hours to paint your house, it would be 30 times 10 plus 200. So the cost would be 300 plus 200. So the cost to paint your house would be $500. Okay, so let's look to see how we would graph this linear function. Okay, here's our linear function. C is equal to 30t plus 200. So, at no hours, you're going to start off with $200. And then for every hour of increase, you're going to increase by $30. So $30 would be your constant increase or your slope. And remember, on the last screen, we said that if you work 10 hours to paint a house, it would be $500. Let's check it out. So right here would be 10, and if you go up here, you'll notice it's telling you for 10 hours it would cost $500. So there is what your linear function would look like if it was graphed. All right, let's look at another example. Okay, here's the last example we're going to look at for today. A scientist is studying the growth of a polar bear in Alaska and records the data in the table below. Is a linear function an appropriate choice to model the weight of the polar bear? Explain why or why not. Okay, for it to be a good model, it would have to graph as a linear function, which means it would have to have a constant rate of change or a constant slope. Let's see if we have a constant rate of change. Okay, if at 2 it weighed 45 pounds, and then at 4 it weighed 150 pounds, that would be a difference of 105. Okay, and then if at 4 years old it was 150 and at 6 years old it was 345, that would be a change of 195. Okay, so if we look at this example, you went from a change of 105 to 195. So that is not the same rate of change or the same slope. So this would not be a good model for a linear function. Okay? We'll get into more functions on later lessons. I want to thank you for watching, and don't forget, study, study, study.